This video will be covering factoring, more specifically factoring by the GCF, factoring trinomials, and factoring polynomials. This is a very important skill to get good at, and it'll be used in the rest of your math career. So let's get into it. Factoring by the greatest common factor involves finding the largest common factor that all the terms in an expression share and then factoring it out. So step one will be to identify the GCF of all the terms in the expression. The GCF is the largest number or variable that evenly divides into all the terms. Step two will be to write the GCF outside the parentheses, and what remains inside will be the reduced expression. And then step three will be to divide each term of the original expression by the GCF and write the results inside the parentheses. So let's do some examples. So for this first example, we are going to find the GCF of these three terms. So we start out by finding the factors. So 21, we know the factors can be 1 and 21, or 3 and 7. So we can go to the next one, 14. We know 7 goes into 14 two times, and also 1 and 14. But for 54, 7 does not evenly divide into 54. So the only common term will be 1 in 54. So the greatest common factor of these three terms will be 1. Example 2 is asking us to factor 9x plus 81. So using the GCF, we know that 9 can go into 81 9 times. So we can factor a 9. Then 9 goes into 9 one time, which will be 1x, but we'll just put x, plus the 9 goes into 81 9 times, so we'll put a 9. And then that will be the factored expression. Example 3 is asking us to factor 7x squared plus 7x plus 42. The first two terms, 7x squared and 7x, both have a 7 and an x, but the last term, 42, does not have an x. So we cannot factor out an x, but 42 is 7 times 6, so we can factor out the 7. So we'll factor out 7, which will leave us with x squared plus x plus 6. And that is your factored expression. Example 4 is asking us to factor the polynomial x cubed plus x squared plus 7x plus 7 by grouping. So we can group x cubed plus x squared, and then we can group 7x plus 7. So x cubed plus x squared, then plus 7x plus 7. Now, in the first expression, x cubed plus x squared, we can factor out an x squared, which will leave us with a x, and then plus 1, because x squared goes into x squared one time. Then plus, then 7x plus 7, we can factor out as 7. So 7, then we'll be left with an x, plus 1. 7 divided by 7 is 1. Now, in this polynomial, we can factor out an x plus 1. So we'll factor that out, x plus 1, and we'll be left with x squared plus 7. And that is the answer. So factoring trinomials, you're going to use the form ax squared plus bx plus c, where a, b, and c are constants. Here are some simplified steps. Step 1, you're going to find the factors of AC that sum to b. Then you're going to rewrite bx using the numbers from step 1. Then step 3, you're going to factor by grouping. So let's do some examples. Example 1, we have x squared minus 8x plus 15. So a equals 1, b equals negative 8, and c equals 15. So we need to find the factors of a times c that add to b. So 1 times 15 equals 15. And we know factors of 15 are 3 and 5. But we need these to add to negative 8. So we can add a negative sign before each factor. Then so these will equal 15 when multiplied, but add to negative 8. So now we're going to rewrite bx using these numbers. Minus 3x minus 5x plus 15. Now we can factor by grouping. So x squared minus 3x, we can factor out an x. So x, then we're left with an x minus 3. Then minus, we can factor out a 5, so minus 5. Then x, left with x, and we'll be left with, we're factoring out a negative 5, so we'll be left with negative 3. We could factor out x minus 3, so we'll be left with x minus 3 and x minus 5. And that is the factor trinomial. Example 2, we're going to be factoring 4x squared plus 9x minus 9. So in this problem, a equals 4, b equals 9, and c equals negative 9. So 4 times negative 9, a times c equals 36, negative 36. And so we need to find the factors of negative 36 that add to 9. Well, we know that 12 times 3 equals 36. Or 12 times negative 3 equals negative 36. And 12 plus negative 3 equals 9. So we rewrite bx using these numbers. So 4x squared plus 12x minus 3x minus 9. Then we can factor by grouping. So 4x squared plus 12x, we can factor out a 4x. So 4x, we're left with an x plus 3x, or actually plus 3. We factored out that x. Then negative 3x minus 9, we can factor out a negative 3. So minus 3, we're left with x plus 3. So now we can factor out an x plus 3. So we're left with x plus 3. Then 4x minus 3. And that is your answer. So for example 3, we have x squared plus 12x plus 11. So a equals 1, b equals 12, and c equals 11. So the factors of a times c that add to b, so 1 times 11 equals 11, and the factors of 1 and 11 that add to 12 can be 11 and 1. So 11 times 1 equals 11, and 11 plus 1 equals 12. So we'll rewrite bx using these numbers. Plus 11x plus 1x plus 11. Then we can factor by grouping. So x squared plus 11x, we can factor out a x. So x, then x plus 11 plus, and then 1x plus 11, we can factor out a 1. So 1, then x plus 11. So we can factor out now x plus 11, x plus 11, then x plus 1, and that is your answer. Example 4, we have x squared minus 16x plus 63. So a equals 1, b equals negative 16, and c equals 63. So we need to find the factors of a times c that add to b. So 1 times 63 equals 63, and factors of 63 can be 7 and 9, which equals 63, but we need them to add to negative 16, so negative 7 and negative 9, so negative 7 plus negative 9 equals negative 16. So we'll replace the bx with these numbers. So x squared minus 7x minus 9x plus 63. Now we can factor by grouping. So we have x squared minus 7x. We can factor out an x. So x, we're left with x minus 7. Then negative 9x plus 63, we can factor out a negative 9. So negative 9, we're left with x and negative 7. We could factor out now x minus 7, which will leave us with x minus 7, then x minus 9, and that is your answer. Next, we're going to do the difference of squares. So the formula for difference of squares is a squared minus b squared equals a plus b times a minus b. So let's do some examples. So for example 1, we have x squared minus 49. So our formula, a squared minus b squared equals a plus b times a minus b. So x squared minus 49, which will be 7 squared, equals to x plus 7 and x minus 7. So x plus 7 times x minus 7 is your answer. Example 2, we have 25x squared minus 4. So our formula, a squared minus b squared equals a plus b times a minus b. So in this example, a squared, 25, we could write it as 5 squared times x squared minus b squared, which negative 4 can be written as negative 2 squared, equals then 5 squared and x squared. We can write 5x squared minus 2 squared, which then equals, so our a will be 5x plus b, which is 2, then a again, which is 5x minus b, which is 2. So our answer will be 5x plus 2 times 5x minus 2. Next, we're going to be doing perfect squares. So the formulas are a squared plus 2ab plus b squared equals a plus b squared. Then a squared minus 2ab plus b squared equals a minus b squared. So let's do some examples. So for example 1, we have x squared plus 18x plus 81. then the formula over here. So notice how the first and last term are perfect squares. So we write x squared plus, and then 81 we could write as 9 squared. And then notice how 2ab, so if we 2 times 9 is 18. So we can write this as 2a and then b. So now we have it in this form. And so we write a plus b squared. So x plus 9 squared, and that will be your answer. Example 2, we have x squared plus 16x plus 64 in the formula. So a squared plus 2ab plus b squared. So a squared will be x squared. Then b squared, 64, can be written as 8 squared. Then if we look 2ab, 8 times 2 is 16, so we can write 2a, which is x, and b, which is 8. So now we can a plus b squared, we can plug it in. So a is x plus b, which is 8 squared, and that is your answer.